Let, let's start. Hello, all. Welcome to our today's DSA journey with this amazing DSA visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. So today we will start a new thing which is binary search. Okay. So search halves the search spaces, then search the answer, not the array. Okay. Let's deep down it. So suppose you were given a dictionary. I hope you guys see a dictionary. I hope. I know it's an internet age, but I think you should know how a dictionary works. So in dictionary, if you say that if you need a word, simply like let's take, okay. So you don't know where this word is. You don't know. So first you open your dictionary just on a random page and you found the page having everything, like everything with G, like good. So in a dictionary you reach the G, but you want this car. So how could you go? So if you open in an English dictionary from left to right, so we are reading every text in English. You found the good. Now your task is to find the car. So you go backwards or leftwards because C is coming first and then somewhere G, like in English alphabet, how it works. Okay. But how could you know that if you found G, you have to way, or in the book you have to go to the left part of the book, not the right part, because in dictionary everything is sorted in a text order. Like first it will started with A, then it will started with B, then C. So when you found G, you know C must be somewhere in the left. So you come to C and you found like COTTON, cotton. Okay, but you need car. So the C is common. Now you check the next word. It is O. So O and A. So you again go to left. This is how dictionary work. Similarly, binary search works. Okay, let me give you an example. Integer. How do you search 5 here? Okay, so you were given this array of numbers. How do you search this 5? Like we need to put a loop and go to every element. Okay, but the worst case, the for loop or the while loop take big O of complexity, time complexity. But you can easily found this 5 with big O of log n time complexity. Okay, we have to reduce this to this, and it is much more smaller than this big O of n. Okay, but how? Suppose you take suppose you take G, then you go to the left, you found this word with C, then you again go to the left to found your desired word. Okay, somehow you just come, pick a random element, like pick 2. Now, is 2 less than 5? Is 2 greater than 5? Or is 2 equal to 5? Uh, which of the three is true? This is true. This is false. This is false. Okay. It simply implies that the 5 is bigger than this 2. So it simply means 5 always put into the left part of this array. And why always put? Because we are given you a sorted array. Every time in binary search we have to make sure you will have a sorted array. But how could you pick a number like 2 in random so that you can vary with your target values. Okay, our target value is 5. Okay, so for that I need to copy this, paste it. Okay, so we don't use any randomness. So first, what is the size of this array? 7. Okay, and what is the starting index? 0. What is the ending index? 6. It will be like 1 2 3 4 5. So this is our total index. Our array size is 7. Now calculate the middle of the array. And how could we calculate the middle of the array? We have to calculate it by the use of indexes. Okay, let's suppose this is our lower indexes. This is the most lower indexes. This is the most high that we ever get. Okay, 6. So we have to calculate middle, m, which is nothing but l plus h by 2. Okay, so 0 plus 6. So 0 plus, and this is 0 plus 6 by 2. It is simply 3. And this is the index, not any value. This is nothing but index, mid index. It is index. Okay, so what is the index? 3, 4. Now, is 4 less than 5? Yes. If 4 less than 5, it simply means the 5 actually stays in between this. This is mid. This is mid. In between this mid and high. Yeah. It is simply that 5 is present in between this mid and high. Okay. So now for the next case. For the next case, I have to take this. Now, for the next case, what we are doing is this. We will first need to search in this left part between mid and high. So, how could we calculate mid? We calculate mid using this left and this high, this low and this high. Okay, so take this low and put it to the medium next. So this is our mid previously, and this is how. Now in between this we have our search space. Okay, simple. We got our search space. Now again calculate mid, which is nothing but 4 plus 6 by 2. 4 plus 6 by 2, which is 5. And what is 5? This index, this one, this is our current mid. Is 6 is greater than 5? Yes, it simply means it, the value actually remain this part, more specifically this part. Okay, till L, till L, from the middle till L, we have to just remove the middle part because the middle part is not equal to our target. Okay, so just take this. Now now this middle plus is, we have to take the value between this low and the middle. Okay, so now the high, this high, okay, this high goes to mid minus 1. Now now okay, now just take the mid again, which is nothing but low is also 4, high is also 4, so it is simply 4 plus 4 by 2, which is simply 4. So 4, what is at the 4 index? 5. So 5 is equal to 5. Yes, we got this. we got our answer. Okay, and how many operations we did? Here, calculate like this. We did, start it from here. This is number 1 operation, calculating mate. This is number 2 operation, calculating this mate. This is number 3 operation, calculating this mate. Okay, there's 3 operations to target our 5. And what is the size of the array? 7. So log base 2 7. Calculate this value, log base 2 7. Okay, if we go here, it is C, it is 2.807354. okay, and if you take the ceiling value, which will become 3, so we got our answer. Like, it is simply 0.8 and our answer in 3. So if you take the ceiling value in this index, we are taking value, it will become 3. So with just 3 operation we found 5. But if we do a linear search in this array from the start to this 4, we have to do a 5 operation. Okay, and we got it in 3, which is much more better. But here is one condition, the array should be sorted. This is a simple condition. So what we will take, first we calculate mid. We have to calculate mid using left plus high by 2. Then simply do one thing, check like a of, let's suppose m is equal to our target or not. If it is, simply return it. If a of m greater than our target, okay, if a of m, our value, is greater than our target, that's how we get the 6 here. What we do when we get a 6 as mid? Here we just move the high to the left, which is nothing but mid minus 1. I will become mid minus 1. Okay, if a of our mid, our array of middle value, is less than t, this is our, this one, like this one, we got 4 but our target is 5. So what we did, we put our left to here on this 5. So simply do a left or low equal to mid plus 1. So these 3 are our actual condition, and this is our calculating mid formula. But we are using different formula for calculating mid, which is L plus high minus low by 2. And if you just do further calculation like L plus h by 2 minus L by 2, which will become L by 2 plus h by 2. And if you take the LCA, like L plus h by 2. But why we use this, not this? Okay, the reason is simple. If any time we are given a very long array, like 2 to the power 30 values as size, so you can either have to use a long in the mid, so L plus h, okay, by 2. So when the computer calculate this and L value is very much large, like near about 2 to the power 30, and h value is also like near about 2 to the power 30, like minus 30 and 2 to the power 30, like it is 0 plus it is 30. So when it will add everything, it will go index out of bound. Okay, there is a solution for this. For this higher value, you have to use a long. But if you don't want to use a long, you have to use this value, because every time we are actually adding these two values, we have half them first, then actually we are adding them. Okay, so when computer did this, he will starting with this mathematics, where he first remove the value from the high. Okay, because h minus l. So this is our simple formula. We will be using this. If you want to use this, use a long. Simple for bigger cases. Okay. I think we have to go to the solution. That's simple. Uh, let's go to here. Given a sorted array of distinct integer and a target, return its index or -1 if it is present. Must run in big O of log n. Okay. So given an array of integer nums where the sorted array in ascending order and the target is find the function to target nums. So if you want to do, you can run as like I am doing this. Don't do this. Like a for loop for int I equal to 0, I less than n, I plus plus. Okay. Then simply if nums of I will become target, we have to return the index and we have to return, okay, we have to return simply index. So return I, and if nothing present, simply return -1. Okay. You can run this too. This will also work. Also submitted, but there is a restriction check. I don't know it's failed in restriction or not. I think it passes all the test cases. See. Okay. For loop perform a linear search resulting big O of n. Okay, let me copy this. The error. Yeah. So the for loop performs a linear scan resulting the big O of n time complexity, violating the big O of log n requirement. Okay. So it is a restriction failure, but it works in every. So if you see, I previously done it with, no, I don't do it with binary, without binary search. So it runs every test cases, but is false because we have to check in big O of log n time. Okay, log n time. So let me write down the pseudocode first. Like we are given an array and a target t. We have to calculate starting with L from 0, and our high will become n minus 1, the last index. Always started with these 2 pointers. If you can see here, see, this is our mid and this is our mid. The mid is this 3 is less than 9, so our low will point to this 3. So it goes to this 3, and again we are calculating this mid and we are getting our answer. Simple. While our condition run until this condition. Okay. I calculate the mid. Our mid, or let's take it m, which is simply L plus h minus L by 2. Okay. Then if the array of mid is equal to target, then simply return the mid. Let's take it as mid. And else if array of mid is somehow greater than the target, then simply high will become mid minus 1. And else is array of mid is less than the target. If array of mid is less than the target, so low will become mid plus 1. And at the end, simply return -1 if we don't found the value. So just evaluate it. Okay. It gives an error because of I have to use H here. Okay, rethinks in 10 seconds. It is a long time. So this should be our. Let me check. Yes, we did it. Now do a simple thing. So take L, which is from 0, and take R, which is nums dot size minus 1. Simple. while simply L is less than equal to our R. Okay, I am taking R here, I am using H there, so let's take it as H. This is our simple condition. Okay, simply check the mid, which is nothing but int mid equal to if R minus L by 2. So if nums of mid is equal to target, then simply return the index, which is the mid. Else if the mid is greater than the target, the high would become mid minus 1. It simply means we reach a value which is much more greater than our target, like we reach G but we need C, so we go to our left twice. So we are using mid minus 1. Then else simply do that it is lower. So when it is lower, doing a mid plus 1. And at the end, simply return minus 1. Let's run it and check it. And it would give an error. This is H. Too frequent. Subscribe. Let's check it. Let's run it. Because LeetCode using a restriction check, you have to make sure to solve it in a desired complexity. Maybe the test cases pass, but not that. Okay, so this is our simple binary search. How we apply binary search here? It is take big of log n time and big of 1 space because we don't use anything. Use this thing or use long. Okay, but you can use the formula according to this constraint also. Even the constraint are much more lower. You can use L plus H by R, L plus H by 2 also. But I am preferred using this because it works in every condition in every data type. Okay, like integer, double, not double, integer or long, everything. So this is how the question simple binary search. This is our simple binary search. So go use this platform, use this link, this one, use this one to get a 7-day free trial. Use this platform at dsa.chaicode.com. Thank you very much.